So our final topic in limits is the existence of a limit. We have a definition here. It says that the limit of f at x as x approaches a exists if and only if the limiting value from the left equals the limiting value from the right. So we'll use this notation for our left limiting value and our right limiting value. If they are the same value, then the overall limit exists and is equal to that value. Otherwise, we will say this limit does not exist. Okay, and as always, remember that f at a does not need to exist for the limit to exist at a. The limit simply describes the behavior of f at x around a. So first of all, let's look at this graphically, and then we'll do this algebraically. So can we find the limit as x approaches -1? So as we approach -1 from the left, we're coming down towards the y value of 1. But -1 from the right gives us a y value of -1, and therefore we say this limit does not exist. Around the x value of 1 from the left, our y value is going towards 1. And from the right, our y value is also going towards 1. So this limit does exist and equals 1. And remember, it's okay that f at 1 is a whole. That is not what the limit is talking about. It's just talking about the behavior of f at x around a. So algebraically, let's find the limit of f at x as x approaches 2 if it exists. So with a piecewise function, we've got two pieces and they are, well, actually they're not joining because one's less than 2 and one's greater than 2. So at 2, they're like f at 2 is not defined. But let's see what's happening around 2. So to the left of 2 are parts less than 2, and to the right are x values greater than 2. And so the function to the left is x squared plus 1, and the function to the right is 4 plus x over 2. So let's find our limit from the left of f at x is the limit of x squared plus 1. We'll plug in 2, so that's 2 squared plus 1, so that gives us a limiting value of 5. Now let's go from the right, and this is the limit as x approaches 2 to the right of 4 plus x over 2. So note my need for brackets because this whole expression, we want to find the limit of it. And we can sub in 4 plus 2 over 2 is 4 plus 1, and that equals 5. Great. So since the limit as we approach 2 from the left is equal to the limit as we approach 2 from the right, and those limits are equal to 5, then the overall limit as we approach 2 of this function is equal to 5. Okay, for good communication, you need to replicate this statement. Okay, this is the logic behind our argument. It's using the definition. Since the limit on the left equals the limit on the right and it equals this certain value, then this overall limit equals that value. Okay, let's do one more. This time the limit as we approach 5. So here, this is interesting. We do have a value at 5, but again, that value doesn't even matter. We really want to know what's happening to the left of 5, which is x squared minus 5x over x minus 5. And what's happening to the right of 5 is the root of x plus 20 minus 5 over x minus 5. So let's find the limit approaching 5 from the left will be the limit as x approaches 5 of x squared minus 5x over x minus 5. Okay, so this one's problematic. If we plug in 5, we get divide by 0. So we're going to have to clean up this limit by factoring makes us x times x minus 5 over x minus 5. There we can cancel out the factor that causes 0 over 0, and then the limit as x approaches 5 of x is 5. Now let's do the limit from the right side. Is going to be the limit of the root of x plus 20 minus 5 over x minus 5. Also a problem here, if we plug in 5, we are getting actually 0 divided by 0. So let's clean this up using our conjugate binomial. Oops, 5 from the right. This is x plus 20 minus 25 over x minus 5, and this root x plus 20 plus 5. Our numerator cleans up to x minus 5, which is great. That will cancel out with the problematic part of our denominator. So 1 over the root of x plus 20 plus 5. Then we can sub in, so that's 1 over the root of 25 plus 5, which is 1 over 10. Oh dear, our limit from the left does not equal our limit from the right. So let's make our conclusion. So since limit as we approach 5 from the left, note I have to write f at x because limit without a function is like, what do we say? Like my mom would say, like an apple pie without cheese or a kiss without a squeeze. It just doesn't work. And the limit as x approaches 5 from the right. So these things are not equal. Therefore, the limit as we approach 5 of f at x does not exist. Thank you, Katie, aka Lindsay Lohan. This limit does not exist. So that finishes up our work on limits. So it's the value that a function, it's a limiting value that a function is approaching as x gets closer and closer to some value. We can solve or evaluate limits graphically, algebraically. We know how the properties of limits work, one-sided limits, and how to use the one-sided limits to determine whether a limit exists or not when you don't have a graph to be able to visibly see that. Okay, so thank you for your work.